In this video, we're going to talk about base number systems. To understand numbers in different bases, we first have to understand the system that we use. The system that we use is a base 10 system. What this means is that when I write a number like 356, each of these digits has a value based on where it is in the number. So we know, for example, that this is the ones digit, this is the tens digit, and this is the hundreds digit. So that would mean that this number, we have 3 100s, and we have 5 tens, and we have 6 ones. So that is the meaning of this number 356. So that if I wanted to write a number in a different base, the digits would be powers of that base. All right, so let's look at our base in more detail. We only have 10 symbols that we can use. They are 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Now actually, as I said these, I said the numbers that they represent, okay? So this symbol here is the symbol that we use for the number 1. This symbol is the symbol that we use for the number 2, and so on. So all of our numbers are formed with these 10 digits. We have a base 10 system, and we have 10 digits to use. Once we get past 9, we have to write our numbers using 2 digits. So because we have the ones place, we get 9 ones, and if we want 10, we have to go with 1 10 and 0 ones, which is why we write 10 like this. Okay, so we have 1 10 and 0 ones. All right, so our system, no matter how many digits are in the number, all of the digits are some power of 10. So the ones, or 10 to the 0, the tens, or 10 to the 1, the 100s, or 10 squared, the 1000s, or 10 cubed, the 10,000s, which is 10 to the 4th, the 100,000s, which is 10 to the 5th, and the millions, which is 10 to the 6th, and so on. So these can go out to any number of digits. So anytime I write a number, I know the value of the digit by its place in the number. This is why we can tell the difference between 356 and 3056. Because in this number, the 3 is in the thousands place, we know that it's really worth 3,000. Whereas in this number, since it's in the hundreds place, it's only worth 300. So this is how base number systems work. So let's change the base to base 5. So if I have a number in base 5, first of all, I only need 5 digits, right? Because in a base 10 system, we use 10 digits. So in a base 5 system, we only have 5 digits. We have 0, 1, 2, 3, and 4. So all of our numbers will be written using these digits. So now, if I write a number like 324, this no longer represents 324 because the 3 is not in the hundreds position anymore because we're in base 5. Okay, so we'll just subscript this to remind ourselves that we're in base 5 here. So since we're in base 5, all of these digits represent powers of 5. So when you have a number in base 5, the first digit here is the 5 to the 0. This will be the 5 to the 1. This will be the 5 squared. This will be the 5 cubed. This will be the 5 to the 4th, and so on, just like we did up here with the base 10 numbers. So when I have a number like 324, that tells me that I have 3 5 squareds, I have 2 5s, and I have 4 5 to the 0s or 1s. So 5 squared is 25, this is 5, and this is 1. So I have 3 25s and I also have 2 5s, and I also have 4 1s. So in base 10, this number would be 75 plus 10 plus 4, or 89. So if we have a number in any base, we can easily convert it to base 10 by simply writing it in its expanded form in its particular base. So let's look at another example. Suppose I have a base 7 number. Then I would only have the digits 1, 0, 1, 2, 3, 4, 5, and 6, because I only need 7 digits in a base 7 number. So if I have a number like 423 in base 7, then the digits represent the 7 to the zeros, because we're in base 7, the 7 to the 1s, and the 7 squareds. So 4, 2, 3. I have 4 7 squareds, or 4 49s, because 7 squared is 49. And then I have 2 7s, and then I have 3 1s. So 4 49s is 196 plus 14 plus 3. So 196 plus 14 is 210, plus 3 is 213. And thus we can convert from any base to base 10. Now, suppose I have a number in base 12. Okay, so since it's a base 12 number, we need 12 digits. So we can use 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and now we have a problem because I can't use the way we write 10 in base 10. I need a symbol that represents 10, and I also need a symbol that represents 11. So I need to have 12 individual single symbols to represent the 12 numbers. So what we do in this case, because we only have in our system symbols from up to 9, we'll just make some additional symbols. We'll let A and B represent the values 10 and 11 respectively. Okay, so just like this symbol represents the number 9, this symbol is now going to represent the number 10. So every time we see the A, we should associate it with the number 10, and every time we see the B, we should associate it with the number 11. So now a base 12 number might look something like this: A3, 2B. Okay, so what does this mean? Well, again, since it's a base 12 number, all the digits are powers of 12. So we have the 12 to the zeros, we have the 12 to the 1s, we have the 12 squareds, and we have the 12 cubed. All right, so in other words, 12 to the 0 is 1, 12 to the 1 is 12, 12 squared is 144, and 12 cubed is 1728. So that means that this number here, if I have an A here, a 3 here, a 2 here, and a B here, I have A 1728, or in other words, A represents 10, right? So if I want to convert this to our system, I have 10 of these 1728s, plus I have 3 of these 144s, plus I have 2 of these 12s, plus I have B, which, remember, B represents the number 11 of these 1s. So, putting this into a calculator, 1728 times 10 is 17280. Then 3 times 144 is 432 plus 24 plus 11. So 17,280 plus 432, I'm just entering this into a calculator now, plus 24 plus 11 is equal to 17,747. So in base 10, our base, we would represent the number this way.